Well, let's have another case. Case 3. Let's put case 3 there. This one is very interesting. Very nice. Wait for it. Case 3. Alright. Let's assume again the very same object of mass m. But now we are interested in a force that is the gravitational force. The object is still being displaced to the right, like that. So what is the work done by the gravitational force? Again, our definition of work, F delta x cos of theta. Our force of interest is Fg. Our delta x is still delta x. But what is theta? The angle between the gravitational force and the displacement is how much? Theta is 90 degrees. So that means we have cos of 90 degrees. But what is cos of 90 degrees? Cos of 90 degrees is just a 0. 0 times anything makes the work done by the gravitational force becoming a 0. Now, what does this mean? It means any force that is perpendicular to the object's displacement will do no work on the system. That is a very powerful conclusion, and you need to remember it all the time. So it could have been the normal force. This force would have been perpendicular to the displacement. So this force is doing no work on the object. So any force that is perpendicular to the object's displacement does no work on that particular system. Let's look at case 4. Case 4, we've got an object, again the very same object. It's still being displaced to the right. But let's assume that we've got an applied force at an angle alpha there. Now we are interested in finding the work done by this particular force. You go back to a definition again. Work is equals to F delta x cos of theta. Our force is F, our displacement is delta x, and our theta in this case, how much is the angle? Remember, theta is the angle between F and delta x. My F is there, my delta x is on the horizontal like this. My delta x is on this line. So the angle between F and delta x is alpha. So I'll have cos of alpha there. Alpha can be anything, be it 10 degrees, 5 degrees, 30 degrees. So whatever the value you'll be given in that calculation, you'll put it there, and then the work is going to be F delta x cos of whatever angle is given as alpha. And this is your work. Keeping in mind that, remember we just said work is measured in joules. So because this was just theoretical, we were not putting the units, but remember to always put joules in each and every scenario. The units of that particular work is joules. So that's how we calculate work.